So the to evaluate, so let us see the big O notation and how to find the time algorithm complexity for various algorithms. Okay, first of all, you should know the major factors which determine the big O notation. First is to evaluate the efficiency of the algorithm. The two major factors are considered: time complexity and space complexity. Time complexity is that nothing but number of iterations required depending number of iterations required, which depends on the size of the input, whereas space complexity is nothing but number of storage space required with respect to the input. So based on the time complexity and space complexity, we are going to fix the algorithm's complexity. Here the big O notation is used to classify algorithm according to the running time and space required. So that is why we use big O notation, which considers only these two factors, which is the running time and space required depending upon the input size. Okay, so these are the various big O notations of the various searching and sorting algorithms, which is split up into best case, average case, and worst case. Okay, so linear search has best case big O of 1, average case big O of n, worst case big O of n. The binary search has big O of 1 as best case, big O log n as average and worst case. Insertion sort has big O of n as best case and big O of n square as average and worst case. Selection sort has has big O of n square for all the three cases: best case, average case, and worst case. And the merge sort has big O of n log n for all the three cases. Okay, as I say, it is big O of n and square 1. You don't understand anything, right? So we are going to see why this particular big O of 1 is, we have got it as a best case for linear search in detail. Not only this particular case, we are going to see for all the cases why this happens and why this big O of n square is the average case for the selection sort. Okay, let us see now. So if you want to know why this particular notation is the best case, then don't forget to see the below mentioned videos links, okay, in which I've given a detailed video. So before going in detail, we'll just see the need for the calculation of the complexity. To find which algorithm is suitable for the particular requirement of the user, we calculate this complexity. That is, some user may require high time efficiency and low storage efficiency, and the vice versa. So with the help of the above comparisons, we can find the suitable algorithm. Okay, so there is a need for finding the complexity of algorithm in all those three cases: average case, best case, and worst case. Okay,